Hi everybody, welcome to SMR Telugu Education. So EMP ERR of 100. So employee size is 40 bytes, then memory is allocated for 440 into 100. So 4000 bytes of memory is allocated. This is memory is waste. This is a static memory allocation. This one is not recommended. So here by using malloc function, here allocate the memory for one element. How to allocate? EMP so PTR is equal to EMP star malloc size of EMP. Since this memory is allocated for 40 bytes, here the memory is allocated for 40 bytes. Here some base address is 500. So this address is stored in PTR. So this is PTR. This 500 is stored in PTR. Now the PTR is pointing to this address. Now we have to enter the values. SN ID name salary. Here I am entering employee ID name salary. Now this size is, after some time one more employee is come, then this size is increases. That means here memory is allocated for 80 bytes. So this data is copied into this location. Now this address is 600. So this should be replaced with 600. Now this one is pointing to this address. This one is deallocated. So after some time one more employee come. Next memory is allocated for 40. Here the address is 700. Now this value should be replaced. We are entering the data here, entering some data ID name sal. ID name sal. So one more thing, here the same data is copied here, this same data is copied here, this data is copied here. By using realloc function, we have to copy this same code into this one. Now this value is changed with 700. Now this one is pointing to this address. This one is deallocated. Next one more employee. Next you have to enter here, you have to enter ID name sal. ID name sal. So one more employee, once again memory is allocated So id, name, sal, first employee, second, third, fourth. Here the same data, this one is copied here, this one is copied here, same data, this one is copied here. The address is some address 800. The same data is copied here, this data is copied here, this data is copied here. Once again we are enter id, name, sal. This should be replaced with this address 800. Now this one is pointing to this address, this one is deallocated. Once again here we are enter id, name, salary. So this is memory efficient. For first employee, memory is allocated only 40 bytes. For second, 2 employees 80 bytes. Okay. And continue and so on. Memory is efficient but performance is down. First memory is allocated, once again deallocate and copy, once again memory is allocated. Okay, right. So this one is okay but not recommended. For this solution is, so the solution is linked list. So by using linked list, so this is the structure, struct name, employee, so int id, char name of 36, next int salary, so type def struct emp, capital emp, semicolon. Now another structure, struct link. Here the data is employee, so empe. Next self referential structures, so struct link asterisk, this pointer variable name is next. For this struct link, so alias name is type def struct link, so alias name is link, link capital. Now the memory is allocated for link. How to allocate? So malloc size of link. So here what is the size of link? Here struct emp size is 40 bytes. This one is 40 bytes of memory is allocated. Struct link, this size is 40 bytes. This is the pointer. So all pointer sizes are equal. Here the semicolon. This size is 42 bytes. Now malloc size of link. This statement allocates 42 bytes of memory. So 42 bytes of memory. So this one is E, this one is next. Next, this one is E. So once again, E is ID, name, salary. This one is ID, name, salary. So this one is ID, name, then salary. Here the base address is some 500. Now this one is which type? We have to type by default. This is wide asterisk type. We have to assign this one to link asterisk. That's why we have to typecast to link star. So assign to some variable, some any variable. Here I am assigning to PTR. Now, so instead of PTR, starting node is head node. Better to take this one as head. Now, so memory is allocated for head node. So this one gives the base address. Base address is 500. This 500 is stored in head. Now this one is 500. Now this one is pointing to this address. Now I am entering ID is 100. So name is SMR. Salary is 16,000. So next is no node. That means next node is null. This is the first node. So one more, after some time, one more employee is entered. Then you have to allocate the memory for This one is E. This one is E. This one is next. So E is the employee. Every employee had ID, name, salary. Once again, this one is ID, name, salary. So initial values is garbage values. ID is 101. Name is Kushal Kumar. Salary is 15,000. Next node is null. Here the address is 600. Now this 600 is stored in the previous node. This null value is replaced with 600. So this value should be replaced with next node address. The next node address is 600. So this one is 600. Now this node is pointing to this one. Here head node is 500. So next node is 600. So once again, one more employee. So memory is allocated. This one is E. Next one is next node address. So once again, E employers ID, name, salary. ID, name, salary. Here some address 700. So ID is 102, name is Manvita, salary is 14,000. Next node is not available, null. Here the next node is 700. Now this one is replaced with 700. Now this one is pointing to this address. So this should be continued up to the end. This is a linked list. So one more link. So memory is allocated for memory is allocated. So here E, data memory is E. Here the data memory is next. Some address 800. Here I am taking every employee's ID, name, salary. Here entering some ID 103, some name Lakshmi, Shanmukh Varma, and salary is 17,000. Next node is not available, then you have to null. This 800 is stored here. This 800 is stored in this address. $800. Now this one is pointing to this address. So in linked list, in arrays the continuous memory is allocated, but in linked list there is random memory is allocated. This is 500, this is 600, this is 700, 800. No need to continuous memory. It may be sometimes 600, 800, 900 and 1000 and so on. Any number, random memory is allocated. So in first case, in this case memory is waste. This is static memory allocation, not recommended. This one is okay, valid, but performance is down. Every time memory is allocated. Okay, so once again deallocate, copy the data once again. Okay, so performance is down. In linked list, this is dynamic memory allocation. In linked list concept, insertion and deletion is very easy. If you want to insert data in third node, easily you have to insert the data, and deletion is very easy. The performance of linked list is better than compared to static. So now onwards you have to discuss in data structures concept. You have to manage the data by using linked list concept. So one more thing, arrays are linear data structures. Sequential continuous memory is allocated, but in linked list random. But this is also a linear data structure, but this data is in random order. Any order it is stored. So in linked list, insertion deletion is very easy, but in arrays insertion and deletion is very difficult. You have to move the data from either backward or forward or any direction. Insertion deletion is very difficult in arrays, but in linked list it is very easy. But here in linked list concept, here extra some space is there to store the address of another node. Some memory is extra. So this is linked list introduction. So this is called a self-referential structure. We can define same structure variable pointer as member to the same structure. So still you have any doubts, please refer once again. Thank you for watching.